direct, and for this presentation number 1. So before we start our presentation today, I would like to seek your cooperation to put your handphone in silent mode so that we can avoid any interruption during the session. So for presentation number 1, our moderator for today is Yang Berbahagia Professor Emeritus Datuk Dr. Haji Ismail bin Haji Bakar. He is Head of Research Center of Soft Soil in UTHM, and also one of the Technical Working Committee for the guidelines for construction on peat and organic soils in Malaysia. So without further ado, I would like to invite Datuk to be the moderator for this session.
Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon. Thank you very much for everything. Let me just correct one small information, incorrect information. I'm no longer the head of research. Now, just an ordinary researcher at research. Okay, so again, welcome back. Probably since we have only one screen, for those who are staying there, if you want to enjoy the slideshow, we have to move closer to this side. Okay, in the interest of time, in the interest of trying to finish our program in the stipulated time, I would like to probably skip some of the introduction of the speakers. With the the speakers has also agreed that they do not want to be introduced at length. When they're looking at it, they said whatever is written in this booklet is already described themselves. So let me just, with that, call the first speaker. I would like probably to also remind the speakers, since we have time, our time is limited, can we probably limit to 20 minutes, and then whatever remaining time we will have for Q&A. All the Q&A will be done at the end of the presentation after the 3 presenters have already presented their speech. Okay, let me call the first speaker, which is Professor Raihan. Professor Raihan is now the director of LESTARI, and Professor Raihan, as you all know from the UKM, and also he used to be one of my students, so that means to say I'm very old. So okay, thank you very much. Let me just pass over to Professor Raihan.
Thank you very much, Dr. Ismail. Thank you for the kind introduction, Dr. Ismail. Once a student, always a student. So the topic of my presentation is something to do with nanotechnology and sustainability in the construction industry. I've been working with this topic for a number of years, and the content of my presentation is, I'm just going to skip this. Well, 15 years ago, when I first gave my talk on nanotechnology in construction, I have to talk about 90% of the topic on nanotechnology. But now, I think 15 years from that time, I don't think that I need to introduce nanotechnology anymore. So it's, you can find it, and then most of you, I think, know what is it already. So as a start, this is a bridge, Gannenplatzbrück, in Germany, inaugurated in 2007, and this bridge will not be completed, could not be completed without the UHPC, and UHPC would not be UHPC without nanotechnology. So this is just to show that nanotechnology is already coming into construction, whether you want it or not. Well, because our team of the conferences beyond 2020, we would sure that nanotechnology will be in the scene very soon, or if not, is there already. So this is one of the bridge. This is just a footpath, and a real construction is the Wilbrook in Wolkemat, Australia. This is also made by the help of nanotechnology, which is in the UHCP. So in terms of UHCP, the conventional concrete are in this range. This is about 10 millimeters. And high strength concrete, you need some fillers. And in order to get UHPC, you need some nanomaterials right at the bottom of the scale. So nanomaterials will be required to get this UHPC to increase the strength of the concrete. In terms of sustainable development, I'm sure this is the first slide that you all know, you have read about it. I'm not going to go about it, but I'm going to touch the current sustainable development goal, the SDGs. If you may, after this, go to the SDGs and look at the 17 goals that has been set by the United Nations with 169, I guess, targets. So this replaces the sustainable development concept now. But anyway, the beginning of the sustainability is with this Brundtland Commission. He nicely defined this to include what I think is very important is the future generation. We have to keep something for the future generation. Whatever we have now, we have to mind the future generation. In terms of the nanotechnology impact and contribution, and this has been written by, published in the journal Nanoparticle Research. Okay, nanotechnology is often touted as an important contributor for sustainability, and it helps in energy production, climate change, resource depletion. But not only that, we also like to have this urbanization and social disintegration to help we in the future generation. So nanotechnology not only it helps the science, it also help in the social part of the equation. So in terms of our natural resources, in regular textbook you will find all these things. We have our materials, abiotic, non-renewable, and biotic materials, renewable. So all of our construction materials are mainly non-renewable. Of course, some of our materials are renewable, agriculture, forestry, like wood, timber, but we know that all those are depleting. And in terms of the other natural resources, we have water, land, and air. And there's one more natural resources which is very, very important in terms of sustainability, which is the ozone layer. So ozone layer is, I consider it as a natural resources because without it, we are nowhere in this world. We are going to have a lot of health effects without this ozone layer, and we know that it's depleting day by day. So in terms of nanomaterials, use of nanomaterial for sustainability, we target it into three main functions: effective pollution breakdown, substitute for environmentally unfriendly materials, and the focus of this lecture is for improvement of materials. We want to use it efficiently, we want to use it innovatively. By using small, tiny amounts of nanomaterials, we can get huge benefit from this effect. So these are some of the common nanoparticles, nanofibers, nanomeasures for performance enhancement. And example, we have nanosilica particles and also nano-aluminum and nanofibers. So these are already in the market. You can easily buy it from a lot of companies. So these are the materials that can be used for high performance and self-compacting concrete. If you are in the concrete business, these are the materials now available for ultra high strength with exceptional energy absorbing capacity. Paint, this is also a product in the market, and paints and finishing materials with self-cleaning properties. You know that with nanomaterials here, the water particles will not stick to the surface like this. Okay? This is the surface here. We have a nanomaterial that prevents it from sticking to the surface. And of course, the self-cleansing technology, another system where we have a catalyst. We put it on the surface, and with this catalyst, there's no pollutant that can be absorbed on the surface. Another chain coating material that protect our steel from corrosion and also enhance the thermal insulation for window glass. These are all the things that you can have in the construction right now. These are all available materials, although it's not common in this country, but in the Western, like America and Europe, these are all well developed and well used. Smart stressing composite, carbon nanotube sensors. This technology, we get it from our friend from south of the border, and using nanomaterial, we can use it as a sensor. By putting carbon nanotubes into the concrete, we can use it as a sensor to get the material behavior, the strength, and so forth of the material. Self-healing concrete. As you know, in concrete, you can put all these micro capsule with the catalyst. So once there's a crack coming in, so automatically this healing agent will be invoked. And with the catalyst, you will have all these healing agent polymerized into a strong material. So this is a self-healing concept, already well developed. And you know, steel with nanomaterial can become a material or steel which is 5 times stronger, 5 times more corrosion resistant, and 3 times stronger than conventional steel. And again, I would like to draw your attention to this carbon nanotube. Carbon nanotube is one of the earliest nanomaterial, and it has been dubbed as a solution looking for a problem. So a lot of problems, especially in the environment, especially in the electronic industry, come to a nanotube for solution. So it is a solution looking for a problem. So you can use it in many ways in the construction industry. A lot of research has concentrated on using concrete. That is like the research on that part is already like saturated. So if you are interested in using carbon nanotube in concrete, there's so much of it already available. And in terms of price, look at the price. When I started this project on nanomaterial, when I need to buy it in 15 years ago, it's about 2,000 euros per gram. And look at the scale now. This is what I bought like 5 years ago. It's about 1 euro cents per gram now compared to 2,000 euros for 15 years ago. So the price will decrease and will make buildings or construction cheaper with this technology. These are some of the research that has been done using nanomaterials for construction, and this is using metal kaolin. We can see that using carbon nanotube, it can increase the compressive strength quite a bit, compared from 45 to up to 60, using tiny amount. So this carbon nanotube, we never use it beyond 0.5 and 1%. We use it normally in this range, 0.2, 0.5%. So very tiny material, although it's expensive, still expensive, but compared to cement, but we use it at a small fraction, 0.1% maximum. These are some of the results on our study on soils. Again, you can see that the benefit for using nanomaterial is very, very clear. again, in this we studied maximum of 1%. This is as far as we can we go normally. So this is nano-magnesium and this is regular magnesium. So nano-magnesium, we can see that it developed a strength from 100 over here to 600 kPa for soil. And in terms of fire resistance, we conducted this study and we found out that with nano-silica at 700 degrees, we can still remain its original compressive strength with nano-silica. So that's good, and indeed we at 400 degrees, the strength increases up to 180 degrees. But the good thing is that under fire, we can still maintain the relative compressive strength at 100% of the original strength of the concrete. This is something to do with soils again, in terms of cracking, cracking soils and cracking for soil liners. Definitely we can see that the use of nanomaterials will reduce the crack intensity factor quite a bit here, from over 1% to less than 0.3% with the use of nanomaterials. In terms of moving forward and challenges, this is in terms of training of engineers. I think everybody in Malaysian universities in engineering know that we have to put this PEO, the program educational objective, in our system, in our syllabus. And not only that we put it in our program educational objective, we have to show how we can get the students to be aware of this environment and sustainability. We have to show in our class, in our tutorials, and in our exam that we have this element to train our future engineers. So in terms of future engineers, I'm quite confident that they are all aware right now, because all of them are being trained with this in mind. In terms of processing, people are saying that when you process nanomaterials, you have more waste, but no. We have green chemistry and green technology and green processing, which is now very, very well established. We use only the required materials for our nanomaterials, so there are less wastage and very minimal wastage in this system. So funding for sustainability, this is one major thing, and always we see that we have to do more with less. And in our university, the same thing. They give us less grant, but we have to publish more, we have to do research more. But so therefore we have to be more creative and resourceful, and we have to not only we have to use this 3R concept from this from the environment, is reuse, reduce, and recycle. We must continuously advocate and to promote, maintain resource availability, use less landfill space, use less energy, and again leading to sustainability. This is very, very important, because with less money, now with more problems, we really need to be educated, and the last thing, that to more innovative. So we have to be more into education and innovation in order to be sustainable with less money. So in conclusion, I have discussed all these topics, and from sustainability, natural resources are diminishing, nanomaterials can aid our sustainability of natural resources, and I have mentioned the application of silicon oxide and carbon nanotube, and also the challenges in education, toxicity, funding, and financial innovation. With that, thank you very much.